get here, but it is not 6 in the morning. I would be like 6 in the morning.
I don't know if I'm gonna like want to wake up at 8 a.m. all weekend.
Right. I mean, we could do it in the afternoon if you would rather come after lunch or something and spend the afternoon. The nice thing is I can get in here. It's very cool. The last time I ran a AP test, so scary because it's a giant campus, right? And so they had an alarm system. So I had to go in, run because, you know, you open the door, you got 30 seconds to run through the administration building, outside, down into the sub-basement to open up the panel to type in the code to disarm it. But then I set off another alarm. And, and then the police came. It's like, crap. Anyway, so it's much easier here. I have a key to get in. How nice is that? Okay. Anyway, so think about that. I do want to give you guys a practice exam. I also want to give it to you on paper because I think there's a big difference between what you write down on paper versus what appears in front of you on a screen. Okay. Now your test is on a screen. Nothing will be written down. You will be allowed scratch paper, which we will be collecting at the end. But everything will be on screen, and I want you to recognize the difference. Scores will be lower because it is online. You are less inclined to write stuff down, and I want you to think about that as you're doing it and say, you know, when we were doing the paper test, I sure wrote down a lot more. Takes an extra second, but you know, the other problem is when it's on screen and then you copy it down and you maybe transpose a couple of numbers, right? And so it's definitely, you want to be aware of the differences in how you test on screen versus how you test on paper. So I do plan to give you a paper test, but it takes so much time. I don't want to take it away from class time, so we will do it some weekend, and you guys can decide when. We'll talk more about that later. So let's talk about this slope field. This is the last unit in chapter 7 here. Slope field is a graphical representation of slopes. It is a slope field. It is a field of slopes obtained from a differential equation. So they're giving us an equation for the slopes, and we are basically making miniature slopes, and that's all a slope field is. It is miniature slopes. Okay. So remember, a differential equation involves a derivative. The derivative represents slopes for a function. We learned how to solve differential equations by separating variables, but even if you cannot separate the variables and integrate, you can still use a differential equation to plot essentially the solution. So we can plot the slopes, absolutely, because we have the equation for the slopes. And then you can sort of figure out what a solution might be based on what it looks like here in the slope field. So example 1, we want to find the slopes given by the differential equations, negative xy at the following points. So we have this equation. We have an x value and a y value, and all we have to do to find the derivative or the slope at 3, 2 is plug in the values. So the opposite of x would be negative 3 over the y value of 2. For negative 1, 3, our slope would be the opposite of x, so 1 over 3. For negative 2, 1, the opposite of x would be positive 2 over negative 1, which is just negative 2. And the last one, the opposite of x would be negative 2 over negative 2, which turns to, of course, positive 1. Why can't you find slopes when y equals 0? Yeah, because in our expression here, our equation for the slope, we'd be dividing by 0. So we can't divide by 0, of course. It is undefined. And what's really important is that when we have an undefined slope, you draw nothing, okay? We cannot draw it. You do not draw a vertical line. That does not exist, okay? So you draw nothing. when you have something that's undefined. So that's really important. Here, example 2, we want to find and plot the slopes given for the above thing that we just did, for each remaining marked dot on the coordinate plane at the right. And so you'll notice there's no dots on the x-axis. That's, of course, when y is equal to 0. We can't plot anything there. There's no dots that we need to graph. You can see here they've got little lines. These little tiny little short little lines represent the slope at those points. So at 3, 2, you can see we had the slope of -3/2. You can see that the slope is downhill in a negative, fairly steep way. We want to plot the slopes for these other open points here. Let's see. So I'm just going to go 2, 2. dy dx evaluated at 2, 2. That would be -2/2, which is -1. So how do you plot these? At the point 2, 2, I need a slope of down 1/1. If they did ask you to do this on a free response, it does come up probably once every 5 years. It was on the 2022 test. So if they do ask you to plot, you do have to be fairly accurate with your little slope pieces. And in order to do that, this slope means down 1/1. So if I were to draw that slope, I would think to myself, I'm starting here and I'm going down 1/1. So you pick a target point and say, I'm headed towards this point, and that's how you draw your little slope line, okay? So give yourself a little target to head for, and that's really how you do that. Let's see, we also have another ordered pair here, maybe 1, 2. 1, 2 would be -1/2. So at this point, again, I'd be going down 1, right 2. So I'm headed for this point right here. So I want to aim towards that point, down 1/2. All right. You get the idea? It's pretty easy, right? This is like Algebra 1. Plotting slopes here. Let's see, I'm going to plot this point, -1, 1. The slope at -1, 1. I'm also modeling how you would model this, like do the problems, how you'd show the work necessarily. So -1, 1, the opposite would be +1/1. So that's just a slope of 1. So I'd be aiming up 1 and over 1, so aiming towards 0, 2 there. Make my little slope. dy dx, I got another ordered pair here at -2, 1. Let's see, the opposite of x would be +2/1. So that would be up 2/1. So I'm aiming up here. All right, the other slopes, I'm going to say, let's see. I'm going to do this one just to see what it is. 1, 3, dy dx evaluated at 1, 3. That would be -1/3. So I have to sort of down 1/3, be aiming for this point out here. Pretty shallow slope there. And here we would have, let's see, a -3, 1, that would be up 3/1. So pretty steep slope there. All right, so as we were to get through here, all these slopes sort of go like this. It would take a long time to do this, and I just don't want to do anymore. Do you have any questions about getting these slopes? Yeah, pretty easy, right? All right. So they sort of go like this. Anyway, as you're developing these slope fields, what sort of shape are you seeing sort of develop here in this slope field, a field of slopes? It sort of looks like a circle, doesn't it? And so you're exactly right. If we were to, now we can actually, oh, you know what? I think that's the next part. In example 2, you made what is known as a slope field, starting at point 0, 1. We're going to follow the slope, the flow of the slopes to sketch the solution curve containing the point 0, 1. So 0, 1 is right here. And what we're going to do is sort of follow the flow. And as Bree said, it looks sort of like a circle. Your graph should be parallel to the slope lines and be like an average of the slopes if we're getting close there. Whenever it goes between the lines, your solution curve must represent a function. This is very, very important. A circle is not a function. And so whatever we draw in our slope field that represents our solution curve passing through this point, it has to be a function. It can't do any undefined things. We can't cross that undefined delineation, really. Whose domain is the largest possible open interval containing the given point. So in order to do that, here we are at 0, 1. And as you said, it sort of looks like our slopes here, we had a slope of 1. So as we move to the left, we're going to get, and basically I'm going to sketch, so as we approach, it sort of mimics those curves. Now this is a hard one just because there's not a lot to go on here. Now, as I get to y equals 0 here, this horizontal line, I can't really draw anything there because I know it's undefined when y equals 0, but it does get infinitely close. I'm going to go ahead and just draw open circles there. Because it is undefined, we know we're getting very, very close to that y equals 0 line. So there's the solution curve through 0, 1. Sketch the solution curve passing through negative 1, 1. Well, that's right here. Negative 1, 1, I'm going to be sort of parallel running in that slope of one direction. At 0, 2, the slope is 0, and that's something we didn't really do. But so I'm going to sort of approach hitting sort of a maximum there because the slope of 0, and then we're going to go back down. You never want to like cross one of these slope fields. You want to sort of run parallel or just grazing by it, but you should never cross, like if the slope field is this way, your curve should never be like that across it. All right, so you want to be a little careful. Again, I'm going to use open circles there on my x-axis. So they do look like semicircles. We're also going to draw one passing through 0, negative 3. So 0, negative 3, again, has a slope of 0. And again, I'm just going to be sort of above this one again. So my orange line is very much parallel to the slope at 1, negative 3 there. Then it's so they do get, should have probably drawn a few more slope fields here, but you'll do that a little bit later, so no big deal. Pretty easy there. Once you get all the slope fields in, it's pretty easy to see how they should go. And again, all of those three different curves are all functions. They all pass the vertical line test. And so what type of graph does this differential equation seem to be producing? Well, they seem to be semicircles. So he says the most common student error in sketching these particular solutions to a differential equation is to extend the sketch too far and create a graph which is not a function. So it's really important that you're always making sure that you don't draw too much, just don't pass any undefined places, and make sure you extend the graph as far as you can, making sure it still remains a function. All right, so it's important to set appropriate boundaries for your sketch. Y is the x-axis the boundary, because that's where y is equal to 0 and it's undefined. And we can't cross that, of course. Okay, so it's a semicircle. Let's see. Example 4. So we're going to actually solve the differential equation. What should we do first to solve the differential equation? Yeah, we're going to multiply by y and multiply the dx to the other side. So we get y dy equals negative x dx. Then we can integrate both sides. What is the integral of y to y? Y squared over 2. Y squared, I'm going to do 1/2 y squared. And the integral of negative x dx. Negative x squared over 2, or negative 1/2 x squared, plus c, don't forget the plus c. They give you a point for that on most of the questions. So it's kind of interesting. And usually this first step always earns you, actually it's this first step, the separation of variables right there, on any AP test gives you the first point. So just knowing how to separate your variables earns you a point, and then the derivative plus c earns you another point. So keep that in mind when you're doing free response questions. Every single little bit helps, all right? So don't erase, don't doubt yourself, just go with it. I'm going to go ahead and multiply by 2, just so I can maybe clear some fractions here. I'm going to multiply everything by 2. So that gives me just a y squared equals negative x squared plus c. Now, if you're looking at that, if we were to move that x squared over, you would see y squared plus x squared equals c. What is the formula for an equation of a circle? You remember that? It's a good one. X squared plus y squared equals radius squared. That is the equation of a circle. You notice it's the Pythagorean theorem, essentially. A squared plus b squared equals c squared. It's a circle of the same radius all the way around. So that is the equation of the circle. Solving for y, so if we were to take a square root, to get y by itself, it's going to yield, what do we have to remember when we take a square root? Plus or minus. So important. It yields either positive radical negative x squared plus c or negative radical negative x squared plus c. There is a negative there. There we go. So really important when you're taking that square root, you don't forget the plus or minus. The same is true for a 4th root or a 6th root or an 8th root. So this is the general solution because it's got the plus c's in there. So now we want to find the particular solution, which passes through point 0, 1. So if we have the point 0, 1, which one of these should we use? The first one. The y value is positive here, so we want the equation that has the positive in front. And so we have then 1 equals the square root of negative 0 squared plus c. Which would just be 1 equals the square root of c, and just in case it wasn't just 1, we would square both sides to cancel out the radicals, so we would have c equals whatever that number is squared. It's kind of an easy one. So the particular solution is y equals the square root of negative x squared plus 1. Find the particular solution whose graph passes through the point 0, negative 3. Which equation should we use for 0, negative 3? The second one, again, because the y value is negative, we need to choose the equation that offers us a value of y that would be negative. So we have negative 3 equals the opposite of the square root of negative 0 squared plus c. Negative 3 equals the negative square root of c. Again, we would square both sides. We could cancel, I could divide by the negative. You could cancel out that negative if you want. And then square both sides. So we get c equals 9. A couple ways to do that. So you get y equals the opposite of the square root of negative x squared plus 9. Always a good idea to double check just to make sure you did your algebra right. Make sure that your equation balances when you plug those numbers right back into there. Make sure it works out. I would absolutely do that on an AP test just to make sure it's right. Okay, fantastic. We want to draw the slope field for the dot coordinate plane at the right using this differential equation. So go ahead and plot some slopes and then do part B. We're going to graph. So go ahead and do A and B. I'm just going to pause this. Okay, as I look around, your slope field looks great. Again, there should be a noticeable difference between a slope of 1 and a slope of 1/2 and a slope of 1/3. I will also want to point out that in this equation, everything here horizontally, they're all the same slope. That row where y is equal to 3, everything in that row had a slope of 1/3, right? So this is an important thing to recognize because part of the AP test will be which slope field, or rather, given a slope field, which equation could it be? And so when you're looking, all my slopes depend only on y. So all these slopes are parallel in that y equals 3 line, all right, in that horizontal line. So when they're parallel horizontally, you know the equation only has y's in it, all right? If the slopes were matching vertically, so if all the slopes were the same in the vertical direction, then you know your equation only depends in x's, okay? So it's something to pay attention to as you're going. So passing through -2, -1, again, we know it's undefined when y is equal to 0. So our horizontal line here at y equals 0, the x-axis, has no dots on it. So we know we can't cross that sort of boundary. And then as I'm moving to the right, I'm guessing my slope is getting less and less steep, right? So I think I'm going to go like this. And there we go. All right, all the way to the end. And then I've got to get as close as I can. And that's going to be a little open circle there, even though it sort of looks solid. I meant it to be open. So that's pretty good. And then at 2, 2, right here, again, I'm coming out parallel. And then here, I got a slope of like between, and then hard to do exactly. They give you a fair amount of leniency drawing these by hand. Oh, that's an open circle right there. Okay. All right. Now we want to solve the differential equation. What do you want to do to solve? I'm going to swap out my y prime for dy dx equals 1 over y. And then I'm going to do a little cross multiply here. So we get y dy equals 1 dx. Go ahead and integrate. And we have 1/2 y squared equals x plus c. And I'm going to go ahead and multiply by 2 maybe. So we get y squared equals 2x plus c. And then I'm going to go ahead and square root both sides. So we're going to have y equals either positive 2x plus c or y equals negative radical 2x plus c. It's better to write it out as to 2 things if this were a question you were given on the AP test. But again, they're going to ask you to find the particular solution. All right, so write functions for graphs that pass through these points. Which first piece or second piece should I use for -2, -1? The second piece, absolutely. So we have, let's see, a -1 equals negative radical 2 times -2 plus c. If I were to divide by my negative, those would cancel out. So we have 1 equals the square root of -4 plus c. And then I would square both sides. So I get 1 equals negative 4 plus c. So c equals 5. And plugging that back in, we get y equals negative radical 2x plus 5. Plugging in 2, 2, I'm going to use the first one because it's positive. So we'd have 2 equals radical 2 times 2 plus c. Square both sides. We get 4 equals 4 plus c. So c turns out to equal 0. We get y equals the square root of 2 times x plus 0, which you don't have to write, of course. All right, any questions on those? Pretty easy, eh? Not too shabby. All right, so example 6 and 7, matching slope fields. What you want to pay attention to on these multiple choice, they are super tricky. And so here, which of the differential equations below? So right off the bat, you need to pay attention to these are equations that would represent these slopes. So the very least thing you could do is say, oh, I'm going to take an ordered pair like here. Let's try this one, which is at 3, 1. So I could at least go 3, 1 and plug it in and see if the slope makes sense, right? So y prime would be 3 in this case. Does it look like a slope of 3? Oh. Yeah, and maybe. And you'll also notice that all of these slopes here, horizontally, do they all appear to be parallel? Yeah, they sure do, which tells me this is an must have y's. Y's only. So I wrote must have y's. So right off the bat, I can get rid of that one, actually. And I can get rid of that one. Oh, and I can get rid of that one, because since they are all parallel horizontally, my equation only deals in y's, not x's. Let's see. So they're also all positive. They're all positive slopes, which is kind of interesting. Right here, though, on the x-axis, I have a slope equal to 1. But if I test a point, like this point right here, I'm testing 1, 0. And if I plug it in, then y prime would be 0, not 1. Do you see that? All right. So my equation says my slope should be 0, but here I'm looking at a slope that is definitely not 0. So it can't be that one. So let's check the last one here. If I plug in the point 1, 0, 1, 0, then it says y prime equals 1 plus 0 squared, which equals 1. So that seems to match my slope of 1 on the x-axis there. So I do think it's D. Here, our slope equations match our slope field, okay? But the difference here on number 7, this is not a slope equation. These are the antiderivative. These are the solution curve. So these are the solution curves to the slope field. And so this has more to do with like understanding what solution curves look like. Okay, so e to the x, what shape is that graph? Exponential. All right, Superman graph, so it increases, grows slowly. And we can see, like, if we were to pick a solution, like draw a solution through 0, 3, then I'd be drawing something much like this. Maybe something like that, which was definitely not A. All right. What's e to the negative x look like? Exponential decay. Very good. So that is a possibility. That does decay to 0. So that's pretty maybe good. Negative e to the x, well, that's e to the x that's been flipped. And so that's actually like this. It's been flipped vertically. Negative natural, what does a log graph look like? Yeah, a log graph, but like this one, the log of x has a vertical asymptote and it grows very slowly, very boring. And the negative log function would again be a vertical reflection, but it has a vertical asymptote. And you can see that we don't have that. So I think, what did Gary put? I don't remember. Oh yeah, okay, he did put B. And so a lot of times that is more about looking at the general shape of those curves to see if it fits in between the slopes. Does that kind of make sense to you? The other thing you can do is we can actually take a derivative of this. So the derivative would be negative e to the negative x, and then you could plug in some ordered pairs to see if it matches. And so this becomes a little bit challenging, but I could plug in like 0. Well, we plugged in 0, 3, so I'll do that. If I plug in 0, 3, that'd be negative e to the negative 0. Well, e to the 0 is 1, so we get a slope of negative 1. And that definitely seems like the slope of negative 1 just about there. So I think that could be, oh, you can't see that. There we go. Definitely seems like that could be the slope there. Anyway, so a couple of things to pay attention to. When you're looking at slope fields, are you looking at a derivative equation? So you can plug in just points, plug in ordered pairs, and see if the slopes match. Or if it's a solution curve, we're going to look and see what shape matches, fits between the slopes, okay? You have a little two-part assignment here today. A few problems in the book here. Let's just do 5, 8, 9, and 10. Let's just do 5, 8, 9, and 10. There's a little tear out sheet that you could just do the work all on this extra piece of paper on page 181. And then there's also an AP Classroom multiple choice. I think it's 10 or 12 questions. Oh, and a Delta Math? Oh, look at that. Wow, that's a lot. I'll make the AP practice optional. I put not graded. But oh, just kidding. Just 7.3. Sorry. I changed my mind so much. Let me get rid of the 7173. I'll again, because of our little what was our day? Our evacuation day. Everything got messed up. Okay, so there, I fixed some of that. I do obviously ask that you try to do the AP Classroom questions because they are sort of on another level, right? But if you got time,